Last example that we are going to look at with transformations is writing function rules. So a problem like this might look like given the function f of x equals x squared, write a function rule for g of x that has been, and then we'll do a couple different parts here. So for part A, let's write a function rule for g of x that has been reflected in the x-axis. All right. Well, if we have a reflection in the x-axis, let's think about what transformation is going to happen. Reflection over the x-axis is upside down, so that's a vertical change. Something is going to happen outside of the function. And hopefully you're kind of starting to get pretty good at identifying what these transformations are. That reflection happens when we have a negative outside. So here's what I'm going to do. We have this function, this new function g of x that we want to write. I know g of x is some transformation of f of x here. And if it's reflected in the x-axis, that means we have a negative f of x. So pretty similar to how we were practicing when we did that exploration on the computers. We just want to take this one step further now, because we know what f of x is. We know now that f of x is x squared. So instead of seeing this f of x here, plug in x squared, and then we're done. So g of x equals negative x squared. Gives us what we need. All right, let's write a function rule for g of x that has been translated right 3 units. And I guess I should probably clarify here that g of x is reflected in the x-axis of function f, just to make that clear that function g is a transformation of f. All right, so translated 3 units right. Well, if it's going right, something's happening inside of our function. So we'll start there. G of x is f of something's happening inside here. Translated right 3. Well, right means we have to have the opposite of what we think. It's going to be minus 3. So g of x is really f of x minus 3. That minus 3 is inside. Okay, now I don't know how much you guys remember about function notation, but when we have something inside of our parentheses here, hold that thought for a second. In example A, we just flat out saw f of x. We could flat out substitute that in. Here, we see something in parentheses. We don't just have f of x. so we can't just substitute. We have to use some of our tricks about function notation, and again, I'm not sure how much you remember. So let's come off to the side for a second. I say up to the side, let's come up here for a second. Using this, f of x is x squared. Let's go through real quick, recap how to find f of 3. What does this mean? Well, look at where this 3 is in relation to the x. F of 3, f of x. This number inside of our parentheses is our x value. Whenever we have something inside of our parentheses, f of whatever, that whatever the stuff inside of our parentheses is our x value. So to find f of 3, we plug 3 in for x in our equation. So f of 3 would be 3 squared. Which is 9. Okay, knowing that, let's come back down here. G of x is f of x minus 3. I have stuff inside the parentheses. So the stuff needs to get plugged in for x in my equation. So I'd have g of x equals, take this x minus 3, plug it in for x. That x minus 3 would all get squared. And that's all we need to have as our answer. All right, I'll do 2 more examples here. If you're feeling pretty good, you don't necessarily have to watch C and D, but they're here if you want them. C, let's do, again, function f of x is x squared. Write a function rule for g of x that has been vertically stretched by 4 and reflected over the x-axis. All right, so we have g of x again. And it's somehow related to f of x. We need to figure out how. So I'll start with this. We have a vertical stretch of 4. Vertical is happening on the outside. Our vertical stretch, do we want to add 4 or multiply by 4? We want to multiply by 4. So 4 times f of x. Oh, and then this reflected over the x-axis. Reflected over the x-axis, let's see. X-axis, it's going to be a vertical reflection. So that's happening on the outside again. And it's going to be a negative. Negative 4 f of x. I don't actually have anything inside the parentheses there, which makes our life easier because, again, we just see this plain old f of x. When we see f of x, we know f of x is x squared. Take this x squared, put it in here, we're done. G of x is negative 4 x squared. All right, and last example, let's do 2 translations. Write a function rule for g of x that has been translated left 3 and up 6. Again, I'm going to start off with that g of x is somehow related to f of x. And I'll leave a little space there. For translated left 3, it's affecting my x values. It's happening inside of our parentheses and opposite of what we think. So I need a plus 3 here. Up 6 is plus 6 at the end. Now, just like in part B here, we don't have just plain old f of x. We have f of x plus 3. So to figure out what f of x plus 3 is, take this x plus 3 and plug it in as our x value up here for f of x equals x squared. If I do that, I get x plus 3 squared plus 6. G of x equals x plus 3 squared plus 6.